Thanks for watching. If you find my videos helpful, please like, share, and subscribe. And please look in the description beneath this video for useful links to other videos and resources to help you learn chemistry. For today's video, I'm going to teach you how to answer the question shown here. I invite you to pause the video right now and try this question on your own first, then hit play and I'll show you how to do it. So collision theory is one way that scientists use to be able to explain why different molecules interacting with each other will potentially lead to a constructive reaction that is formed product and why some do not. The idea is basically that inside a container or flask or system, you have molecules speeding around and colliding with each other. Now, some of those collisions do happen in the right way so that they lead to those two reactants interacting with each other constructively so that they form a different new product. And some of those interactions do not. What is the key? Well, there are two things. First of all, those molecules have to hit each other with enough speed. And second, they have to hit each other with the proper three-dimensional orientation. So if two molecules hit each other oriented in an unproductive way, that is where certain atoms on one molecule are not pointed in the proper way to interact with the necessary atoms on the other molecule to lead to the formation of a specific product, then that reaction will not occur. So based on our explanation, according to collision theory, why might some interacting molecules not end up reacting in a way that results in the formation of product? In other words, why might they not react with each other? Well, option A suggests that they might hit each other with too much kinetic energy, so they bounce off each other without reacting. Is that one of the true tenets of collision theory? As I just explained earlier, the answer is no. If the molecules hit each other with too much kinetic energy, assuming that they have the correct 3D orientation, that will actually increase the probability of them reacting. In fact, greater kinetic energy leads to greater reactions. Option C says that the molecules have already reacted with other molecules in the system, leaving no available partners for the reaction. That's just a nonsense, gibberish answer, the kind that you often see on multiple choice exams and problem sets and homework to try and lead you astray with flowery wording that it uses. In any event, it doesn't offer any real explanation, especially built on the tenets of collision theory, so we can cross it off. Whereas option D says that the activation energy is too low. Okay, if my activation energy of a system is really low, is that going to offer an explanation as to why I don't get a reaction happening? No, if anything, it's going to have the opposite. Low activation energy means that the reaction is going to happen more easily. That would actually explain the opposite, why I get more reactions happening, not less. So we can cross off D. And option B says that molecules sometimes collide with each other with an unreactive orientation. Is that a reason why two molecules would interact but not actually undergo a reaction to form product, according to collision theory? Yes, it absolutely is, which thereby makes option B this question's correct answer.